Hey there, everyone. Thanks for joining us on the live stream. Since this is our first hybrid event, we are going to be starting the actual talks in about 18 minutes or so. You can see that there are folks showing up live, and it's going to be fun. But for now, we're doing a little bit of mingling, catching up with some of our community friends. So we will only be going live around 6 o'clock with the talks. So stay tuned. We're around. Feel free to join the Discord, ask questions for our speakers, say hi, tell us where you're joining us from. And definitely stay tuned for the excellent talks that will be coming. Those will be starting, again, like I said, around 6 o'clock. Hey there, friends. Just a quick reminder. This is our first hybrid event. So we will be starting in just a few minutes, 5, 6 minutes. We're letting folks just mingle and remember what community actually is. So they're having a little bit of a good time. It might take a few more minutes. We're letting you see what's going on here in the room and see what's going on here in the 2LB community. So feel free to stick around. And we hope to get started within 5 to 10 minutes. Okay, everyone, we're going to get started. So today we're going to have two very, very awesome talks from the cloud native and production jungle communities. Zohar is going to talk about scale, services, and Ivan from Playtika is going to talk about how they use Aerospike and others to manage their microservices scale up, scale down in a Kubernetes world. We're still figuring out what we're doing with our community events this year, so if you haven't filled out our survey, we would really, really appreciate it to understand. I see that you guys are here, so I'm going to guess that you are willing to come out to events, but just to understand, the size and what's possible. We might put a 2021 event a little bit in delay in true Israeli fashion and have it be maybe at the beginning of 2022. So a 2021 event in early 2022 maybe. It looks like Q3, Q4 is very, very full with events, but we'll see what we're doing. But we will be coming back to Community Summit Tel Aviv. That will include DevOps Days, StatsCraft, and Cloud Native and OSF Play all in one. So that should be great and awesome. And we'll be announcing that soon on our Twitter handles and our newsletter. So if you're not subscribed, tlvcommunity.dev, you can subscribe to our newsletter to receive updates. We have another event coming up May 19th. This was actually going to be reverting to virtual. We're still figuring out the hybrid and virtual and all of that. So this one is going to be a virtual one, but definitely check it out from Production Jungle. It's going to be about scale as well. It's going to be a really interesting one from the team at Workloads. Without further ado, I'd like to invite Ami from Aerospike to say a few words. Come on up, Ami.
זהו?
That's me.
חברים.
Thank you so much for joining us. And
זה
being brave.
הכי מרגש שהיה לי פעם שעמדתי מול קהל. אני אשתף אתכם ממש...
ועמדת מול כמה אנשים.
ועמדתי מול כמה אנשים בחיי, כן. הייתי לפני שבועיים או שלושה, הייתי בהופעה, אחת ההופעות הראשונות נראה לי, מאז שפתחו את החיים, של אילי בוטנר וילדי החוץ, בתל אביב, בן יהושע. החבר'ה עלו לבמה אחרי שנה, בחו, אני מדבר כמובן על בוטנר, כן, על האומנים, כן, פשוט בחו, ואני גם בקהל הצטמררתי, גם עכשיו, ממש 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 מרגש, אחרי שנה, עשינו מיטאפ במרץ, נכון? זה היה מרץ, שנה שעברה, לא רחוק פה בשרונה, בנילסן, אצל הכוח שלנו, איפה דור? לא היית אז, נכון? היית כבר בניו יורק, אז ממש 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 מרגש, וממש כיף לראות את כולם, תרימו כולם כוסות, בואו נעשה לחיים, יש לכולם? לחיינו וקיימנו והגיענו לזמן הזה לחיים. כיף שבאתם. ממש כיף שבאתם. נעשי קוראים אני לאירוספייק ישראל. אני לא רוצה לקחת יותר מדי זמן מההרצאות הטכניות. אני רוצה בעיקר להגיד תודה. קודם כל תודה לצוות של אירוספייק שעזר להרים את האירוע, תודה רבה לאושרת. ותודה רבה לכם, תשמעו אותו, ויש לנו פה גם נציגות של הפיתוח שלנו, שרועי שנמצא פה, אז מי שרוצה גם לדבר אחר כך עם נציג הפיתוח מוזמן. אני רוצה להגיד תודה לפלייטיקה ולאיוון, שעוד מעט תראו אותו אחרי זוהר שיצא. כמובן תודה להגיד לשרון, שאיתנו כבר אני לא יודע כמה שנים ביחד, מהתקופת אפסלייב וכולי. תודה רבה. תמיד כיף לעשות אירועים ביחד, וכנסים וכל מיני דברים ממש כיפים. ואחרונים חביבים, אני רוצה להגיד תודה רבה לצוות של הבריין אמבסי. אז הבריין אמבסי זה המתחם שאנחנו נמצאים בו כרגע, גם המשרדים שלנו נמצאים פה. למי שלא יודע ולא מכיר ולא היה מעולם במתחם של הבריין אמבסי, זה בעצם shared office space. הבריין אמבסי יש היום 5 סופים כל הזמן? 7? אני לא מוסיף לספור, אתם פותחים כל הזמן עוד ועוד. בישראל יש כיום סניף אחד, נכון? ועוד כל השאר איפשהו בעולם, אז זה... כל מי שמחפש shared office space לבן אדם בודק של shared office space, ועד לחברות של כמה הכי גדול, 60-70 איש חברה, ואנחנו מאוד 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 אוהבים להיות חלק מהקהילה של הבריין אמבסי ומאוד נהנים, אז תודה רבה, תודה לניר, ולשירי, ולתמר, ולכל שאר הצוות, אנחנו גם נהנים מהמקום וגם מהשירותים וגם מכל הכיף של הקהילה, אז באמת תודה על האירוח, והכי חשוב תודה רבה לכם, תודה שבאתם, ממש 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 כיף לחזור לחיים, אנחנו כבר מתכננים, אפרופו מה ששרון אמרה, כן אירועים, לא אירועים, כן היברידי, לא היברידי, אנחנו כבר מתכננים אירוע לקוחות שלנו, של אירוספייק ישראל, שאני יודע להגיד מתי הוא יהיה, אבל אנחנו לגמרי כבר בהכנות ראשונות לגבי מתי ואיך מביאים את החבר'ה שלנו מה-HQ מארצות הברית. מי שלא יודע, אנחנו חברה אמריקאית, אנחנו הסניף הישראלי, Aerospike ישראל, הסניף בבעלות של החברה האמריקאית, של Aerospike קליפורניה, שם ה-HQ שלנו. וכמו שכתבתי, nothing is obvious anymore, so זה ממש 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 לא מובן מאליו שאפשר לשבת ולהיפגש ולשתות בירה ולאכול פיצה ביחד. אז בואו נמשיך ליהנות ולבלות, ולוואי שנתראה בעוד המון כנסים בזמן הקרוב. מילה אחרונה, מי שיהיה מעוניין אחר כך, מחר, מחרתיים, עוד חודשיים, להתנסות ולהבין, אנחנו לא הולכים היום לדבר יותר מדי על Aerospike, יש דברים אחרים לדבר עליהם היום, ומי שכן יהיה מעוניין להתנסות בדאטאבייס, בטכנולוגיה שלנו, אז יש לנו את מה שנקרא Getting Started with Aerospike, בעצם שתי אפשרויות ליהנות מהטכנולוגיה, האחת היא בטרייל של 30 יום, שהוא בעצם Cloud, fully managed, שירות ענן מנוהל שלם שלנו לחודש, והשני, זה בעצם לא טרייל מוגבל, זה בעצם Enterprise Edition, Database מלא, כל הפיצ'רים, הכל, אתם יכולים להיכנס להוריד, זה full featured single node cluster, בסדר? אז מי שמעוניין, אפשר להיכנס ל-Aerospike.com, ללחוץ על הכפתור של ה-Try Now, ואתם תגיעו לטרייל הזה. הדבר הבא שצריך כשנכנסים לטרייל, זה קצת ללמוד איך אני בתור מפתח, משתמש, מפתחים, איך כותבים קוד, איך עובד Aerospike וכו'. אז תיכנסו למה שנקרא developer.aerospike.com, ל-Developer Hub שלנו, ושם, כמו שאתם רואים, New to Aerospike, ייקח אתכם ויעשה לכם מה שנקרא guide through, איך בדיוק להתמצא בטכנולוגיה, וגם, ספציפית, בתחילת מאי, יש לנו כנס לקוחות שנתי, לקוחות מכל העולם, שלצערנו השנה הוא יהיה היברידי, גם שנה שעברה עשינו אותו היברידי, שנתיים לפני כן, ב-2019 היה בסן פרנסיסקו, שנה הבאה אני מקווה שיחזור למודל הרגיל, השנה היו שם גם הרצאות ישראליות, היו שם את סייבריז ואת פלייטיקה ועוד מרצה איירון סורס, וגם הרצאות של לקוחות אחרים שלנו, לקוחות אמריקאים כמו פייפל וסוני ועוד כל מיני הרצאות מאוד מאוד מעניינות, אז אתם מוזמנים להירשם לכנס. זהו, אני סיימתי, תודה רבה לכולם, זוהר, the stage is yours. לא צריך, חבר'ה. שומעים?
כן, נוודא ששומעים, יופי, מעולה. רציתי לעשות גם כן את החלק של המרגש, אבל למה כבר גנבתי, אז אני מדלג על החלק של המרגש, ואני אעבור לאנגלית ברשותכם לטובת האנשים שרואים את זה בעולם. So, welcome to our offices, my name is Zohar, I'm going to talk about the power to scale building an application. Before I begin, I want to introduce myself, just in a few words. My name is Zohar Elkayam, I'm a solution architect in Aerospike. I've been in the industry for about 23 years, started as a relational databases guy, Oracle guy, and then a DBA, data architect, CTO, and so on and so forth. And I finished my work as a consultant, and then I moved to a new field completely. So Aerospike is a NoSQL database. I will talk about it briefly later, and I joined Aerospike in 2017. So today we're going to talk about scaling. We're going to talk about the scaling of an application, the idea behind how to scale an application. And because I'm a database guy and I'm a data guy, I'm going to focus a little bit more about how to scale the data layer of an application. We'll understand what is a data layer of an application and how to scale that. I'll give some example using Aerospike as a real world example, but obviously there are other solutions in the industry that you might find relevant. I'll be talking about Aerospike. So let's talk about the challenge of application. So if you have an application, you would like to scale it, let's say if you have a website or an API or something in those vicinities, you might have some kind of a huge application that actually finished whatever it needed to do. So it got to the maximum in terms of being able to handle requests or users or other application incoming data. It might be too many users are trying to access the application at the same time. It's a website and a lot of people are trying to do the same thing all the time. So the general notion would be, okay, let's scale it. And then there are two approaches for that. You can scale it up, add more hardware, add more computing power to that, or scaling out, and then scaling out becomes a little bit flaky because now we need to talk about what it means to scale out. Do we need load balancers? Do we need traffic managers? What does it mean? So today we're going to talk about a little bit about the idea of scaling, and then we'll talk about what it means to scale the database layer itself, database and caching layers as a whole. So in 2009, there was a book called The Art of Scaling the art of scalability, and that introduced a concept, like an idea. When we talk about scaling, we actually talk about three axes. We talk about the x-axis, which talks about duplicating your application and duplicating your data and then trying to go through that vector. Or you can shard your data. You can split the data into different geographies. You can split your data into different types of user accounts and scale it like that. Or the one silver bullet that everybody tends to actually go for is the y-axis, which actually means taking your monolith and breaking it down into microservices and then scaling each part of the application by its own. Don't scale everything at the same time. Just go and scale part by part. And then if we talk about the x-axis, then horizontal duplication of the data means we actually want to take our database, we want to take our application, and then run multiple instances of the same thing. You take the database, you take the application, you put them together, you take a complete copy of the same thing, and then you run it. You have a website, so there will be multiple websites that you will be selling to your customers. If you have a user profile, you'll be duplicating your user profile and having the same base code do the same thing over and over again. But that's a problem. It's a problem because then you need to duplicate your data. You need to find a way to scale it even more after that. And the worst case in that case is that you'll have consistency issues, because if everything is updating at the same time, that might be a problem. It can seem like an easy idea to copying the application over and over again, but on the data scale, that might be a problem. When talking about the z-axis, we actually go into a different direction. We'll take our application and we'll break it into data-oriented areas. For example, if we take different geographies, we have customers in the US, we have customers in Europe, and then we'll take those and split the application based on that. You now don't need to replicate everything everywhere, but your application is now limited in the terms of scaling, because once you depleted the shard that you're working with, for example, the US, then you need to sub-shard it. You need to find a way to split it again. And that tends to be an issue when talking about application. Again, application-wise, it's not a problem. Talking about data, it might be a problem. And then there's the y-axis, the one that everybody talks about all the time. And Ivan is going to talk about it even more and explain what Playtika did with that. He's going to talk about a little bit about why they chose that, both for scaling and for developers management. And then we'll talk a little bit about their Kubernetes deployment and how they use that in that terms. So taking the y-axis and breaking your application into specific little services means now you don't need to look at your application as a whole. You just need to take those itty-bitty parts and handle them separately. And then that will give us the benefits of microservices. For example, the very maintainable and the fact that it's easy to test it. It gives us the loosely coupled of other services. You can upgrade parts of your system without being dependent on other services. It will give you the ability to deploy them differently and take them in separate time. And for me, as a database guy, what interests me is the fact that now the applications are independent. They need to keep their own private data. And when we talk about different services or microservices of the same application using different parts of private data, then some people tend to think that, okay, that means that every microservice is going to have its own database. But that's not true, right? Because you can't keep like multiple thousands of databases. For example, Playtika has over 1,000 different microservices each game. They can't keep 1,000 different services. So there's 1,000 different databases for that. So there are other approaches for that. For example, keeping a schema per service or keeping private table per service. And that would give us the ability to actually have one big database, work with a pattern that is really easy to work with and scalable on the application side. What we need to remember on the application side, or when we're talking about services, is the fact that every time that we think about application and data, we usually tend to keep them together and think about them as a single entity. They usually aren't. Usually when talking about application, we're talking about something that is very stateless. The fact that I can duplicate things over and over again means that it's stateless. But from the data perspective, things are rarely stateless. Questions so far? Oh, hypnotized. Okay, so let's talk about the data layer. What is a data layer? Let's start with that. What is the idea of data layer? So actually we have two things when we talk about data layers. We talk about database, and that's easy to comprehend, but we sometimes take the database and think about it as a cache, and thinking about the cache the application needs in order to expedite the time that takes to retrieve data from a database. And when we do that, that sometimes is the bottleneck. This is the place that we have an issue. And sometimes we have the database layer, and that becomes the issue because the application runs fine, but the database is now the bottleneck of our system, right? So what will we do then? What is the concept? What will we do if we run out of capacity or throughput? Or if you're running out of, or you need more latency, but your database can't provide it, all are true real stories from customers. So what we will do is go back to our first slide, if you remember, which we talked about it, and then we'll be able to scale it up or scale it out. What does it mean on a database level when we try to scale something up or out? So scaling up means on a database there, add more hardware to the same cluster, to the same database. So you're running a MySQL server, you're out of memory, you're out of capacity, you're out of resources, you need to do something, you throw money at it. You add more hardware to it. Sometimes you can do other things, but those are scaling up. When we talk about, scaling out is taking the database and finding the right approach using, again, our scaling cube. The concept and ideas that we talked about earlier. We can scale on the z-axis, where we take the database and break it into shards. Again, talking about scaling those on domain-driven design, or maybe we shard the data on the application side. We'll talk about it in a second. But what we would see usually when we talk about z-axis scaling is going into distributed databases. And I'm going to talk about distributed database in a moment, just to get more into depth in that regard. The scaling on the x-axis is mainly taking the data and replicating it, copying it from region to region, copying it from place to place, having the same data over and over again. And I remind you that I already talked about it, that might become a problem, that might become an issue, because now we're talking about consistency. Okay? The one thing that we rarely see on database levels is going into microservicing your database, meaning having one service, microservice application, or app, using multiple data sources at the same time. It can, we see it, it's not impossible, but we rarely see someone saying, okay, so now in order to scale the database, I'm going to break the different databases inside my microservice. Because, again, that should have been microservice, not a huge service. So on the z-axis, we want to take the database, we want to break it up, we want to scale it out, we want to be able to shard the data and distribute it. And here we see two approaches with customers. They can either shard it through their application, decide that they want to break the application into several parts, talking about finding a way to the special users. They want to find those geographies. They want to find those user attributes that distinguish between different users. Or sometimes they decide that they will take a key and they will just hash it, modulo it, and just share it, break it into different shards, into different parts, very small parts. The second approach that we see people do is say, come on, I don't want to play around with that. I don't know how to do all of those things. Give my database the ability to automatically shard the data in the way he sees fits, or it sees fits. Give the database the ability to shard my data and still keep all of those shards balanced somehow. Keep the database in a place that we can continuously scale it somehow. Because if we are going to do something like that, we want the database to be the source of whatever gives us the scaling, but the application to be blind to that. We can scale the database separately from our application. So when we go into distributed databases, like Aerospike, and here I'm going to talk about Aerospike for a bit, then we talk about the ability to take our database, treat it as a cloud, some kind of a enclosed box, which we don't know nothing about what happens underneath the scene, and allow our application to grow and work with that. And then if we are looking at distributed database, we often see problems like how do you distribute the data across multiple nodes? How would you handle hardware equally? How do you give the hardware the ability to be linearly scaled? Add more nodes in order to add more data or more capacity, more data, more RAM, more disk. How to scale the nodes? How to treat the database when you need to scale it up, but also when you need to scale it down. I'll give an example for that. So we have a few customers that are in the e-commerce realm. That means that Cyber Monday and Black Friday are their peaks. They'll be 2 times or 3 times or 4 times as big as they are in the regular peak. So that means that we need to find a way to not only scale the database and application up, we also need to find a way to scale the database and application down to save costs. And that's not a trivial thing, if you think about it. Because you need to find a way to consolidate data back into less shards instead of more shards. Instead of breaking parts, you need to consolidate them back. And so there are all sorts of other problems, or what happens when you lose a node, and what happens to consistency, and all of those things. And in terms of trying to think about how to do that, then I want to introduce Aerospike just for a brief moment, just to use it as an example, a real-life example. As I said before, there are other solutions. I modestly say we are the best, but you know, they pay me. So let's talk about Aerospike for a second. So Aerospike is a key value. Don't laugh. The Aerospike is a key value cluster database that meant for high throughput, low latency at any scale. And I'll explain that for a brief moment again, because that means we have some kind of a database underneath that microservices often use, and even we're going to talk about it in a minute to explain how they do it. So key value in that regards means that we usually work with a key-oriented approach. And then when we talk about key-oriented approach, we have values that can be more than one value per key. So basically, you should have called it key values database. The values can be scalars, complex, or documents. It's a distributed database, and this is the whole notion of what I'm talking about. We are, from day one, a distributed database. It's built for scale. It's multi-threaded, it's multi-core, it's multi-node. The idea behind this is not something that we patched up after the fact. This is the idea of basically having a database that thinks and acts as a distributed database from the client up. The high throughput part means that we can work in low throughputs, but we can go up to millions of operations per second. It's a latency that it's usually 99% of the time a sub 1 millisecond operation, while being very, very scalable, because one of the things, the magics, how do you do it, is being at any scale, because we are not an in-memory database. We are a database that serves the data from devices. And that means that we can scale from gigabytes to terabytes to even customers who run petabytes. So now that we talked about what Aerospike is, let's solve some of the issues that we talked about earlier. For example, Aerospike data distribution. Now we have data, we need to shard it, we need to split it across multiple nodes, and we need something to go behind the scene and divide the data between different nodes. Take the data, break it into nodes. As I said, this is a database-oriented, this is a disk-oriented database. Then we need that fact to also be able to distribute the data across multiple devices. So every device will give us the same amount of work. We'll be able to scale it because we add more nodes to the cluster, and that will allow us to scale easily. From the application side, it doesn't care. For it is black box. When it needs to fetch a record, the application will automatically know where to find the database, where to find the data, where to go and fetch the record from there, because there's no proxy in the middle. So again, the ability to scale, the ability to add more resources. The replicas, the addition of nodes, the removal of nodes, the idea that we can go and scale your database separately from your application is the main idea behind what makes Aerospike a great scaling tool, and what makes Aerospike the driving engine in what Playtika is doing in their databases. And we'll talk about that in a minute. Questions about distributed database?
Yeah, one question.
Yes.
So it means that application, if it fetches a query, it's not going to one shot.
Because you're, sorry, I'll repeat the question. I know you. Okay. So the question was if we're querying data, if the client goes to more than one shard. And the answer is no, because on the client side, we will know by the key to which shard the record belongs to.
Yeah, it's one record.
Yeah, when talking about key value operations, Aerospike, a key value database, that's the main idea. When we're talking about a secondary index query, for example, we go to all shards simultaneously, know how to fetch from all shards at the same time, and filter the data to return to the client from wherever the data is.
So there is no way to distribute the data if I know where it pattern to go to one shot.
Yes, there's no way to data locality the thing. On the other side, there's no hot spaces because of that. Because if we hit it wrong, we would go always to the same shard. We'll always hit the same node of the cluster. And that is not scalable. It will never be scalable. The basic idea behind Aerospike is being able to distribute the data evenly across all nodes and not being dependent on the knowledge of a customer or user to shard their data correctly. If we know how to share the data and distribute the data across all nodes, then all nodes give the same performance, they do the same amount of work, they work together in order to bring the same throughput, basically. And then that would give us later linearly scalability, because when we shift more shards into a new node, that node will be able to give the same amount of work because the data is evenly distributed.
Yeah, but to distribute the value, so if you ask them by secondary indexes, you don't know who we shard.
Right, I go to all nodes of the cluster together at the same time. And the data will always stay evenly, and no single node will ever break because of that.
We can arrange it.
So you had a question from the virtual viewers. So can you compare Aerospike with Cassandra in terms of how it scales data? Cassandra provides the ability to scale the data as we need. Why would we want to use Aerospike?
Yeah, so the difference with Aerospike and Cassandra is trying to create some kind of a ring. It's trying to distribute the data across partitions. Aerospike predefined the number of shards in the cluster and then redistributed evenly across all nodes. So in terms of that, that's the easy answer for how we compared for sharding versus Cassandra. But the advantages that Aerospike has versus Cassandra are not only there, it's also by the fact that we don't need compaction because of the way that we work, the fact that we don't have garbage collection because we're a C program and so on. There are a lot of other advantages on top of Cassandra. We have so much advantages that the ratio of reducing Cassandra to Aerospike clusters is about 1 to 10. So 10 nodes of Cassandra will collapse into one Aerospike node for the most part. Okay, few more slides because my buzzer already said that I'm going over time. The other vector or other axis that we talk about when we talk about scaling, when we talk about databases, is the x-axis. And that means when we need to replicate the data across multiple regions or inside a single region, but have the application do some kind of a balancing between two nodes. We have a customer who does that. The idea here is to have the data reside on two nodes and then find a way to use it as an either active solution or an active passive solution, meaning changing the data on all clusters or all copies of the data, or keeping it to one node and then distributing it to another node. The idea here is to try to find a way to evade consistency issues and more precisely eventuality. Because if you update something in one place, you want it to be immediately in another place. So that Aerospike have a few solutions. Some of them are basic as just cross-data center application, XDR, copying the data from one database to another. It can be from Aerospike to Aerospike. It can be between Aerospike and different types of databases like Kafka and Presto. But it can also be an intercloud solution for geo redundancy. And we even have one mode that is not on this slide, which gives us stretch clusters, meaning actually creating cluster that is stretched across multiple regions where the reads are very high, but the writes are very low because of physics, because we need to wait until a record would go and go back. So that would give users and basically banks and insurance companies the ability to build large-scale, immediately consistent databases across multiple regions. Questions about replication? Good. So my time is up, and I'll just try to conclude what I just said. We talked about scaling. We talked about application scaling very little, and we talked about database, I hope, more than that. We talked about how to co-duplicate the x-axis, application-based sharding, z-axis, microservice, y-axis, which Ivan is going to talk about a little bit more. And then we talked about the data layer scaling and the idea that we don't need to scale the database immediately with our application. We can separate those into two parts, and this is what we showed in this presentation. Again, I remind you there are other tools in the market, but Aerospike is the best, modestly saying that. I'll take questions if you have some. If not, we'll do the magic of bringing Ivan to the screen.
We have a short break, or Ivan immediately. What do you want to do?
I was thinking of introducing Ivan, and just keep going, unless anybody wants a break.
You need a 5 minutes break?
Need a 5-minute break?
2 minutes break, 1 minute break.
We can go directly.
Okay.
So if you have questions and comments, feel free to contact me in this email. I'd be happy to take questions later if you didn't want to ask them here. Thank you very much for having me. Thanks, Sharon, for inviting me. On with the show.
זה הסטרים. לא עונה, מאיזה בחינה לא עונה? זוהר, יש לך את הטימס לאימא? תעזור לשרון. באיזה שעה אמרנו לו שאנחנו מתחילים? כי אולי הוא...
Hey, Ivan. I'd love to introduce you to the Tel Aviv communities. Are you around?
Hi. So, do you hear me?
Okay. Hey, Ivan. Welcome. You have a full house here. You can't see. Maybe turn the camera around just so he has a good idea of how many folks are here to listen to him. Say hi, everyone. We're really excited to have you. So Ivan's joining us from Ukraine. He's going to be talking about Playtika's microservices and scaling story. Let us share his slides.
Okay. Do you hear me, right?
We hear you great. And take it.
Hello. Hello.
We see your screen, but we see like mountains. We're ready to go whenever you are.
Okay, do you hear me, right?
We hear you great,
Yes.
and I'm removing myself from the stream, and it's all yours.
Okay, so do you see my presentation, right?
Yes, we do.
Yeah. Good evening, everyone. So I'm Ivan Vasyliev. I will explain, give you a sneak peek on Playtika kitchen and explain what's going on inside of company on very, very high level. I will not go into details. So I'm working with the group of engineers who are eventually working on some sort of internal platform, and I will give you a brief why. So Playtika currently is not a small business. So it's up to 4,000 employees, many offices, millions of active users for the product, for the games. So this is successful big player in gaming industry. So the challenges a company has, they are obvious, the competitive marketplace. So from engineering standpoint, this means that, let's say, one day of downtime and you can go out of the business because player will find better game, working game. And from the business standpoint, competitive market means that, you need to keep the player, you need to fight for user attention. You need to keep produce the content, you need to keep player busy. So, and Playtika now is several thousand people, but 10 years ago it was 6. And when they started, they probably used someone's laptop or gaming PC to start the backend infrastructure, but apparently the problem at hand is distributed teams as well. So there is a competitive market, enormous growth, private cloud, and distributed teams. So if we will go into standard evolution of architecture, we will move from left side, nice and easy to operate, beautiful, mega generic service, to the right side into some sort of operational hell, and you will step over the middle side, some sort of Frankenstein, not sure why, but you will step over it. So why? So the question is, why to complicate operations? What's going on? So this is the good question, and I will try to give you details, like some perspective, right? And let's start. So in architecture, this is my favorite article about value-driven architecture. So I will give you a summary, and I recommend to read the article. So in architecture, people might focus on wrong value, meaning people will solve wrong problem. And the solution for the problem, components of this solution will be ignored. So this is very, very common problem in architecture. There is another concept, if you're familiar with or not, this is Canary law. Canary law says that if you have some sort of organization structure, this organization structure will copy itself in the software. So basically, if you have IT department, the code to accommodate IT department will be in your software. This is, you cannot escape. And this article tells about inversing the problem. So instead of building software by existing organization, you change the organization to build the software. But you need to focus on some proper value. So how to figure out the value? How to figure out the focus? And this is again very, very common approach. So you have, let's say, problem at hand. You decided that you need a database. You will hire a database person. You will create a room with database people, and you will say, now you are solving problem with our database. You guys, you are database people. There is room for database people. You sit in your room. We don't talk to you. You don't talk to us. Database should work. So this is one approach, right? And you slice problems, like by deciding the database is your problem, you start building a team people around this problem. And this is article explained that this is activity-oriented organization. So the other approach is to define the problem at hand using some sort of different metric. database is not your problem. Database is a tool, right? So, and there is this article focus you on outcome. So you need to create team or group of people focused on outcome, business outcome, value, money, something like that. And this nice article talks about UI development. And this they saying that the same stuff. You need to, your technical layering, partitioning of the work or anything needs to be focused on problem, but you need to pick the right problem to focus. Don't CSS is not your problem. Your problem is some feature on UI, right? And this is, if you're familiar with SOA by Big Blue Book. So SR architecture made the same mistake. There is portal services, there is integration middleware, smart bus. The problem, the technical problems, architecture tried to address. And this is again elephant. And on the right side here is the picture of microservices architecture. And there is a different slice. And see on the top, there is some modules, like on previous picture, modules which is focused on business function, right? So, and this is common guideline, like you take problem domain and build from the problem domain some software. And if you are building database, maybe database is your problem domain, but inside of database you still have like replication, you still have coordination, leader election, and so on. But if you are building consumer-facing application, your problem domain will be payments. Your problem domain user accounts, and so on and so forth, right? So if we like open backend of modern Playtika games, so they build using Kubernetes, of course, using Docker. This is universal runtime for services, and each service, there is technical services, there is business services, but each service is solving own specific problem, and this is not technical problem. So by slicing work between people, we are focusing on solving, we are focusing people to solve some specific problem. And here we have like payments, user account management, some technical services, some business services, and so on. So the sneak peek on the platform is simple. So there is runtime, there is public API, there is databases, and there is modules. And modules solve problems. And if we are talking about microservices, so each deployment of a service, we can use different technologies. So for example, in Playtika, we use Java for the backend, we use Node.js for the backend, we use .NET for the backend. And we have many different databases per particular problem. So as you can see on example, there is a Aerospike used for sessions. There is Aerospike used for user balance, relational database used for payments, and so on and so forth. So because we are focusing people, group of people, to solve some particular problem, they will pick the best technology for the problem. And they will not be tied to some particular, we don't dictate the technology choices. The Docker and Kubernetes is limited, but everything else is flexible, right? So basically, on top of Aerospike, if I go back to previous slide, so most of the services in front end of the game, like backend application for the game, they use some fast NoSQL database, and this is Aerospike. Some of the slower services, there is, let's say, payments. They use relational database because there is transactions, the atomicity is critical, there is bulk inserts, bulk gets, so they use, to solve specific business problem, they use different technologies. And this is allowed by architecture. And if you remember the slides about Playtika challenges, so we need to move fast and we grow, right? So the people come in and come in, so we hire more people and we need to allow them to work simultaneously. So this means that we need to remove impediments and be competitive, and this means that we need to grow wisely, right? And this means that this one on the left side, this architecture on the left side, which is one monolithic applications, if we start adding more people to development of this application, they will start fighting for each other, with each other. They will step out on each other work. And the simplicity of operational side of this left side architecture, we pay for this simplicity in development side. So the more people we have, the more complex it will be, this application, and the more complex it will be to work with this application. So we basically, so we simplified operational side of things, but development side of things, we need to move faster because we need to coordinate hundreds of people, synchronize their work, do release train or whatever. And this means that we will engineer the process to accommodate our operational simplicity. But if we pay the price of operational complexity, we allow many people to work simultaneously and do the job, and we increase time to market. So, but they need to have all the capabilities. They need to have all the capabilities to finish the work they are doing, right? So, in terms of databases, on the front side, we don't use relational database usually because of the scale. But payments, for example, has different scaling requirements. There is, let's say, you have one payment per second. This is not highly loaded service, right? And logins, there is like thousands of logins per second. So this is the scale requirements is different per business problem. And you can accommodate these scaling requirements starting from the actual business problem to hardware, to data store, and so on. So this is very important that you can isolate and work independently on different problems, because you can increase throughput, you can increase amount of content you deliver to the users, and this means that your users will be happy. Your users will receive content, so it's like a long series. There is players who play for years, like 10 years, player is enjoying the game. This means that the game in 10 years, this is like Santa Barbara for him. He is opening the game and there is always something new, right? And so I talked about databases, I talked about different scale requirements per domain, per problem. And Aerospike is not that simple, because we were successful in building on top of Aerospike Graph API database. So we used Neo4j for a while, and then because we did investigation and research, we found that we can use Graph API on top of Aerospike. And this is a plugin for some open source project, Janus Graph. So this means that even like if you simplify the database API, you can use this database API to build more complex database API, right? And this is quite interesting approach. It's NoSQL graph database, but it's API layer, graph API layer on top of NoSQL database. And because most of Playtika backend is built using Spring, Playtika as well created, helped to finish the project. Spring Data, this is integration. I will not show into details. I will not go into details here, but we created some sort of adapter to Aerospike API, so you can work with the Spring Data if your data access layer is simple. Yeah, so I run our presentation a bit faster, so we will have time for questions, like 5 minutes. Do we have any questions? Do you still hear me?
There are questions, Ivan.
I have a question for Ivan.
Okay, there
guiding
are also
questions.
some questions. Wait, where's the camera?
Amazing.
Ivan, can you hear me?
Yes.
Ivan, can you hear me?
Yes, yes.
Okay, so there are also some questions that we received virtually from the virtual stream, and also some questions from here. So we will be asking you
Yes.
this.
Ivan, can you talk a little bit about your Kubernetes deployment and how you utilize Kubernetes for your microservices?
Yeah, I will open the slide, right? Let me. Kubernetes. Yeah, so do you see the screen?
Yes, we do.
Yeah, so basically Kubernetes is some sort of virtual layer on top of hardware. So we are packaging services, microservices as Docker images. Inside of this Docker image is Spring Boot application with health checks and some CI/CD integration into pipelines. So we have some sort of deployment pipeline. And when we feed this Docker image to Kubernetes, it serves as a regular service in Kubernetes. We don't use Kubernetes DNS, we use Netflix library-based RPC, like Eureka, Service Discovery, and Ribbon Chain, and all like patterns implemented in library. But now we are moving into sidecar approach, and maybe we will switch to Istio. I'm not sure if I will give all the. I gave all the details. Do you have further questions?
Are there any other
Yes,
questions?
we have a question over there, Zohar.
We have a question.
Yes, how do you do capacity planning?
The question.
Every team now operates their own services, they have their own demands. How do you know how much hardware you need? You said private cloud, so I'm assuming you're not
Yes.
out there in the public cloud.
Did you hear the question, Ivan? Did you catch that?
Let me repeat. How we do capacity planning, right?
Yes.
Yeah. So basically, yeah. So you're right. We are buying hardware up front, and we are over provisioning usually, overbuying. And capacity planning is calculated per DAO. So we basically know how average game, like if this is online game or offline game, so we know how much data, how much requests generated. We have multiple games, and we can use one game as a reference. And we compare apple to apples. For example, this game has 2 million DAO. This game has 100,000 DAO. So we can compare, like, and say, okay, so the Aerospike knows, like, we have like 3 of them there, and we need 3 of them there, and like I don't know, gateway microservice, we have 20 or 100 there, and we can do the 10 in new environment, something like that. Does it make sense?
Yes.
Yeah, so we are, first statement, we are over provisioning, so we have spare, And second, once we hit the ground and we need to deploy something, we calculate the capacity based on the other beasts we have in the company.
Are there any other questions from the crowd here? Okay, so I'll mute there. I'm going to join here. Sorry about that.
No problem.
Okay, are we okay now? All right, there were a few questions that came in from the virtual viewers. So I'm going to ask them in the order that they came in. So one of the questions was, are you implementing micro front ends?
Yes, usually. We have back office system like for operators, for game operators to create campaigns and so on. So there is backend for front end for sure, and each function has own mini front end, and inside of this function goes to different other functions more generic to implement it. So there is no one big backend from front end, but there is small per function, something like that.
Okay, thank you. Another question was about the payments,
Yes.
payment services that you spoke about. You said that microservices solves a big problem for you, but that payment remains a problem. Can you elaborate on that? It sounds like it should probably be a huge problem, assuming that you have this lag or something.
I'm not following the question. So the payments for what? The function payments in the game, or payments for?
I'll allow them to hear your answer, and maybe they'll elaborate on their question.
I didn't get the question.
The question was
Payments for what?
You spoke about your payment service,
Yes.
and that microservices solves a big problem for you, but your payment system remains difficult to solve?
No, it's standalone, like several microservices which implement the payments callback from different providers. So we use third-party payments, and we just need to receive callback and grant something for the player in the game. So there is different payment providers has their own set of callbacks, and this payment service has all the mechanics to handle the callbacks and integrate with different payment providers. So this is not a problem. I just made the comparison between, let's say, logins, several thousands per second or hundreds per second, and payments, which is quite different load. So, but by using the same database underneath, it's not reasonable.
Okay. And a question about how you structure your teams. What's the team size? Who leads the team? Do you differentiate between back-end, front-end database roles?
Mm-hmm. Yeah, so basically, team should have all the skills to work and implement functions inside of the game. Database is simplified. The Aerospike operations is simple, so the Aerospike is just deployed, and with help of support, it's working, it's stable, and inside of the team there is developers, QA, product owner assigned, maybe DevOps, like UI developers, whatever needed to complete the functions. The designers work in the different pipelines. So the UI screens, usually they have different something pipelines.
Okay. More of a DevOps question. Do you use Canary or blue-green deployments?
Yeah, usually Canary and blue-green is, we try to adopt, but it's too expensive to burn the spare. So we use Canary, and we integrated Netflix Kayenta, which gives automated Canary analysis. This helps a lot because you basically don't need to go over the nodes after the deployment, and even Canary is automatically monitored and judged. So we built Canary pipeline by ourselves and integrated Canary analysis service from Netflix as a third party, something like that.
Awesome. How do you manage your interface definition between microservices, protocol buffers, gRPC perhaps?
No, we evaluated gRPC and protobuf. The problem at hand is not that complex, so we standardize it on REST over HTTP, plus we use Spring Cloud contracts. This is like consumer-driven, some sort of, you can use consumer-driven, we switch it to contract first, so this is test, like build time, contract validation. And this is not protobuf, this is REST JSON over HTTP.
Excellent. I think you might have touched on this, but maybe it wasn't so clear. So do you run workloads on cloud or on premise?
Most of workloads on-prem. There is something in cloud, but most of workloads on-prem, we pay for the hardware upfront and burn it to the debt. Because in gaming, the backend is heavy. Like if we are talking about online game, backend is heavy loaded. Backend is like working at the same time with clients, so this is like continuous load on continuous cost leakage.
Okay. Any questions from the crowd as more questions come in from the community online? Yeah, another question from the crowd here.
Do you have,
I'll need to repeat it, yeah. It's okay.
you have a central infra team, you said your product teams are cross platform, cross functions, so you have a content creative level one. We also have a platform team that builds the actual platform. Who owns monitoring, who owns stuff outside of Kubernetes, who owns Kubernetes.
You know what, Guy, come here. Come here and ask him. Let's join the stream. It'll be easier that way. You know what? I'm going to mute myself here. Give me a second. We have another question from the crowd here in Tel Aviv.
Go ahead. Try again. Long question.
No.
Good.
Yes. Can you hear us?
Can you hear? Good. Nice from Tel Aviv, just one.
Hi.
So do you have a centralized infra team? Like who owns
Yes.
itself?
Yes.
Who owns monitoring and stuff outside of Kubernetes? I guess Aerospike isn't running Kubernetes.
Yeah. So there is people who know how to operate Aerospike. They deploy Aerospike, but we deploy Aerospike. Recently, we started to deploy Aerospike into Kubernetes. So there is a group of people who know how to install and operate Kubernetes. They own Kubernetes and the pipeline which deploys Docker to Kubernetes, including Canary call to Canary analysis. So there is people who create like cook the servers. So there is a different groups, but they communicate like, let's say, Kubernetes team publish Kubernetes as a service, something like that.
So you have multiple Kubernetes services, like each team has their own Kubernetes service?
Not team, each project.
Okay, so each project has its own Kubernetes service, and they manage their own namespaces in whatever way they see fit, if at all. So you have like
Yes.
dozens of Kubernetes instances.
Yes.
Why did you choose this over namespaces?
Isolation.
What?
Isolation.
Isolation.
Yeah, so basically you have different departments, you have different games, you have different people in different offices, geolocation, you remember, right? So you have different people who need to work. If someone don't let them work, they will not work. That's simple.
That's fine, but it also means that they have their own servers, and they run their own clusters, and they own their own utilization and capacity. Yes. They're completely autonomous.
Yeah. You need to understand that
Sort of.
the size of Playtika, there are about a dozen games, just over a dozen games.
Yep.
All of them are independent. They are not like they share some of the resources, like the operations team, but most of the games are truly independent. They have their own users, their own games, their own playability, their own games economics. It's separate altogether.
Organization. This is separate organization inside of organization.
Yeah, but you do have different database instances per
One, for example, Aerospike
No.
wise, they have one per studio, one per game.
Per cluster, per Aerospike cluster.
One cluster per game.
Yes.
And then that gives them the form of isolation that they need. No game will overtake other game.
Yep.
If you have a game who suddenly explodes because Solitaire became super popular, and this is a true story, one day they woke up to find Solitaire with over 1 million new downloads.
Wonderful.
Yep.
How do you do capacity plans?
Yeah.
Now everything is isolated, so no shared resources.
Right, so they're over capacity.
Yeah, there is spare. There is always spare.
Shared spare for everyone.
Not shared, per project.
Yeah. They have a hardware like playing. Yeah. They have the yeah, exactly.
But usually growth is planned. Then planned growth is a lottery, but the growth is usually planned. Marketing team knows, and we plan capacity before they start.
Another question on Kubernetes.
Last one.
Guys, you can go.
One-on-one session.
It's fine, let's go. Who
Yeah.
does the Kubernetes upgrades?
Could you repeat?
Who does Kubernetes upgrades? You need to upgrade.
Kubernetes team. Yeah, but they allow the scripts, and then each project need to pull the update routines and run. And they have disaster recovery, so there is usually standby environment which handles this. You know, in case of issues during upgrade, you are safe.
I wanted to touch on one point that you asked earlier. You said obviously Aerospike is not running on Kubernetes, and Vanya said
it's running.
It is running. So Aerospike can and does run on Kubernetes, including in a new operator that we released recently.
Yeah, the operator we don't use yet, but the hardware nodes, the nodes behind the Aerospike in Kubernetes label it, and this is hardware node. There is special scale flag devices. There's a special Aerospike specific hardware which Kubernetes schedule Aerospike on, something like that.
So it's a stateful set with local storage. It's not centralized.
Right.
Exactly.
Because
more questions from the crowd? From the virtual
You're fine from here, right? No feedback, right? Can you hear me?
Yes.
Yeah, you can. Okay, great. Do you use machine learning? If so, what general types, use cases, and what general types of use cases do you apply them to? Is Aerospike used to provide these models with features?
Yeah, so there is a machine learning department, there is team. The problems is usually obvious, like let's say there is a paying users. You know that user have barrier to pay, so you can track how paying user was behaving, and you can give this growth path to the user, for example, to non-paying users. And if you increase paying users using this statistically matching and guessing the proper progression path, you will get more revenue. This is obvious. There is anecdote software which we use. There is machine learning in anomalies detection. There is machine learning in complaints detection, anomalies, like if there is support use case. So there is various use cases.
Okay. I think you might have touched on this in your conversation with Alex, but how do you do microservices configuration, common settings like database connections, etc., just in case that wasn't specifically covered? I don't remember all the questions.
This is low-level details. It's not covered. So we use Spring Cloud config service, which is REST adapter over Git. Everything is in Git, and we follow GitOps practices. Deployment is a branch. We deploy by the branch. Once deployment passes all the checks, gates, we merge the branch and deployment is done. If you need to roll back, we take last commit or whatever the commit we need to roll back, create additional branch, deploy this branch. If all checks pass it, we merge. And services talk to config service, and deployment pipeline talk to config service using REST, and you can pull the configs via Git client.
Great. This is going to be our last question.
Okay.
Do you use any kind of data warehouse, data lake, data mesh for BI analytics?
Yeah, we are moving to data mesh right now, and obviously Kubernetes will be there, and maybe I will speak, or someone from my team will speak somewhere about data mesh implementation, but we are moving into data mesh as well, right? And data analytics is Spark, and like data lake, Spark, Vertica, something like that. The technology choices are standard.
Fantastic. Thank you so much, Ivan, for joining us. This was a great talk. Lots of questions from the Tel Aviv community.
This is good. Questions is good.
Continue the conversation. That's where you'll be able to find everyone. And be sure to join us for our next meetup, which is happening on May 19th. It's virtual, so you can join us. And it's also about scaling, if it's interesting to you. These are the details. Thank you so much for being with us, Ivan.
Thank you. Have a good evening, everyone. Bye.
Thanks.
Okay.
So,
What a great talk.
everyone?
Did you stop the streaming?